All right, so this is going to be my first try at trying to take a test and annotate, and I don't know. We'll see how it goes. So question one, you have forces that are acting on an inclined plane on a box. It says if the box is at rest, the net force acting on it is equal to. So it says the net force on it is equal to 0. If F net is 0, I just answered the question. If it's at rest, F net is 0, there's no calculation at all. The answer is just 0. So, whoops. All right, question 2 says a 12 Newton horizontal force is applied to a box on a horizontal tabletop. The box remains at rest. Again, that tells me F net is 0, the force of static friction acting on the box. So the box is here. If you're applying 12 newtons in that direction, friction's resisting it and it's static. If it's at rest, this has to be 12 newtons. It can't be more than it. It would go to the left. It can't be less. It would go to the right. It can't be 0. So the answer is 12 newtons. So D is the answer. I don't know why I got kicked out before. Next question, force required to start an object sliding. To start it sliding means you have to overcome FS, is larger than the force required to keep the object sliding at a constant velocity. That's because μs is greater than μk. We've learned that. Because the force of kinetic friction, so basically they're saying the force of kinetic friction, the answer is less than the force of static friction. This is what we talked about. When you're sliding furniture, it becomes easier. So it's D. Hopefully I'm doing pretty well so far. Next question. A wooden block is at rest. Again, I'm going to underline at rest. That means, we've done this a whole bunch of times, F net is 0. If a 10 Newton force applied parallel to the surface is required to set the block in motion, how much force is required to keep the block moving at a constant velocity? Basically, this question is saying 10 newtons is what FFS is. So to keep it moving, you know that FFS is less than FFK. Is more than FFK. FFK is less than that. So the force required to keep the block moving at a constant velocity has to be less than 10 because it's now μk that you're overcoming. The answer to that is C. Different force is applied to each of the 1 kilogram blocks that you see below. This is the force is different to slide them at a constant speed. If they're sliding at a constant speed, A is 0, F net is 0. So that means if you look at each of these blocks, if 3 newtons is required here, the force of friction, kinetic, is also 3 newtons. The force here is 2 newtons. The force here is 5 newtons. And the force here is 4 newtons. So the question, which diagram is the coefficient of friction between the block and the smallest? Whichever one has the smallest force has the smallest mu. The reason why is they all have the same mass, right? Force of friction is mu Fn. If Fn is the same for each of them, the friction just depends on mu. And the smaller the friction force, the smaller the mu. So that one is B. And last one, diagram below shows a granite block being slid at a constant speed. Again, constant speed. A is 0. F net is 0. Which pair of quantities could be used to determine the coefficient of friction? Force of friction is mu Fn. So to find mu, it's the force of friction divided by Fn. So I need that and I need that. So the frictional force and the normal force on the block would be the 2.